નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. સ્ટેન્ડર્ડ 10th, સબ્જેક્ટ સાયન્સ, chapter 12, electricity. Dear students, today we will discuss resistance of a system of resistors. So you know that V is equal to IR. See, we have already studied V is equal to IR, correct? And you also know that, so R is equal to what? R is equal to V upon I. Okay now? See, V is equal to IR, so R is equal to V upon I. So now, you have to find what is the relation with V with the I and R with the I. So you have to find the relation. So you know that conductor wire, see this is the conductor wire, here current flowing is, it depends upon the potential difference across it and as well as it depends upon the conductor resistance. Okay. So we have noticed how the current through a conductor depends upon its resistance and the potential difference across it. So in various electrical gadgets, it means what devices, we often use resistors in various combinations. So we also know that therefore we intend to see how Ohm's law can be applied to the combination of resistors. See, there are two methods of joining the resistors. So in this, series resistor and as well as parallel resistor. See, series resistor and parallel resistor. See, in series resistor, so you see that in which three resistors having R1, R2 and R3. Look the diagram here. R1, R2 and R3 respectively are joined one end to the other. So means what? So in the series means what you are saying? This will be series and this end is joined into another end. So like this. So this is the series connection you are saying. So here the resistors are said to be connected in the series. Okay. And you see the diagram now. In this series, here resistors 1 and resistors 2 and resistor 3. These are all arranged in the series. And in this diagram, we have seen that which one battery is connected, ammeter reading will be there, and voltmeter will be there, current is flowing. So like this we have, and what we have to find here? So we have to find three resistors combining. See, we have to find the combining resistance. So this combining resistance you have to find. Okay, and here you see this one is parallel resistance. See, this one is the parallel resistance. And in this you see combination of resistors in which three resistors are connected together in one end. See, only the ending you see in the one end it is. So like this will be, what you are saying? Series resistors in the parallel. See, these are all parallel to one another. Here the resistors are said to be connected in the parallel. So means what? See, dear students, don't get confusion. See, from the one end like this, see like this will be there, and here like this. So it will be in the one end, same one end will be there. Okay, only one end. And like this you are saying, what you are saying? Resistors in, see, look here now. So this will be resistors in the parallel. So like this, only one end will be there. From here you can see that 2 or 3 resistors. So this one will be the parallel resistors. So dear students, now resistors in series we will see that. So here what happens? So what important things you have to learn in the resistors in the series? See what happens to the value of the current when a number of resistors are connected in the series in the circuit, and what would be their equivalent resistance. So this also we have to find. Let us understand this one. Join three resistors. So that is join three resistors and connect them with the battery. Here battery will be there. Connect them with the battery, and ammeter will be there, and key will be there as shown in the figure. You may use the resistance of values like here 1 ohm, 2 ohm, and 3 ohm. So like this 1 ohm and 2 ohm, and you can put the value here given 3 ohm. So like this, ohms are used, and a battery of 6 volt battery will be used. Yes. How much? 6 volt battery. And now perform the activities. Plug the key and note down the ammeter reading. So, and you can also find that with this resistance you can change also. Here you can positions you can change. R1 will be here, R2 will be there here. So like this way positions you can change. And also ammeter reading also you can fix here. Okay, you can fix here. Here also you can change. See, change the position of the ammeter to anywhere. Ammeter you can fix here or here. And note down the reading. Take the reading. So in anywhere in between the resistor, note the ammeter reading in each time. Do you find any change in the value of the current through the ammeter? So what you have to find here? Can you change or can you notice the value of the current? Change in the value of the current. So we have observed that the value of the current in the ammeter is the same. So here I will be same, dear students. Ammeter noticing the current or reading the current, reading the value of the current. So in the ammeter is the same, independence of its position in the electric circuit. Anywhere in the circuit, the current value will be same. It means that in series combination of resistors, the current is same. The current is same in each and every part of the circuit, or the same current through and each resistor. So everywhere, anywhere you can, either you can change here, ammeter you can change. So the current flow is same, you will find. Okay. See, for example, in the circuit will be 5, here ampere will be, current will be running. So you can use that in this circuit also, in this resistor also 5 ampere will be, and here also 5 ampere, and here also 5 ampere. Means what? Current flow is same in this. Okay, this is the observation we will find. Now we will see the one more activity now. See here, like this arrangement you have to do. This is the second activity. And here what we are seeing that, see, resistor will be 1, 2, 3, and here I1, I2, and I3 will be there. Here I will be, and also V1, V2, V3 will be there. I is same here. Everywhere I is constant. You know that I is same, similar, because this is in the series. You are learning here I will be same. But you see that potential difference will be different, potential different will be changing, and also resistance will be changing. So what you are observing here, resistance are different, and current flow is I is the same, and but the potential difference also will be different. Okay, this is the way. And you know that ammeter reading will be there. Ammeter you have to find first of all with the help of this total. With the help of this, you have to find the potential value. Potential value, you have to find the potential difference, and also you have to find here the R1, R2, and R3 also. So what we will find? So ammeter reading will be there for current value for measuring the current. So current will be same, but V value will be different, and R resistance will be different. So you know that here, so the V potential difference is equal to, here one formula you have to learn. So that is why you know that V is equal to IR. So this formula you have to use here, dear students. Here V is equal to, what you find? V is equal to V1 plus V2 plus V3. So this will find V1 plus V2 plus V3. So V is equal to V1 plus V2 plus V3. So you know that V is equal to IR relations we are doing. V is equal to IR. This relations we are doing that. So that is why V is equal to IR means, so we can put the IR value here. See, look here now. And you have to find V1 is equal to IR1. See, V1 is equal to IR1. So IR1 you can write like this. And V2 is equal to IR2. In this way you can write. And V3 is equal to IR3. So like this diagram you see. Because here current flow is same. Okay, now you see that IR is, see here IR, and here I will be common. So I will be common. So I can write R1 plus R2 plus R3. So in this way you can write. So now what you can do, see this I, both are here same. So that is why R is equal to, so what do you write? R1 plus R2 plus R3. So like this. So means that three resistors in the series. See, current will be same, potential difference will be different, and but the what you are finding, so V is equal to V1, potential V is equal to potential difference is equal to, see, V is equal to V1 plus V2 plus V3. So with this you are running. V is equal to potential difference is equal to the sum of the V1, V2 and V3. Okay, so this you have to remember this one also, and therefore resistance R1, so R is equal to R1 plus R2 plus R3. So we can conclude that when several resistors are joined in the series, whenever several resistors are joined in the series, the resistance of the combination R3 is equal. So R is equal of sum of their individual resistance, and thus greater the any individual resistance. So this one we are learning in the resistors in the series. Now we will see that second one, resistors in the parallel also. See, resistors in the parallel you see. Now let us consider the arrangement of three resistors joined in the parallel with a combination of resistors. Here three resistors, 1, 2, 3. So in the parallel connection will be there. See, first of all here what you have to do with the help of the ammeter. With the help of the ammeter will be reading, you have to take the R1, R2, R3, and with the help of the voltmeter you have to take R1, R2, and R3. Okay, like this way you have to take the reading and arrange the circuit like this, and here battery will be there, ammeter will be there, key will be there, current flow. Okay, arrangement you have to do like this. Now you see that this one is also, you see here, the individual here voltmeter is connected, ammeter will be connected. You have to find the, what you have to find in each resistor. In each resistance you have to find the voltmeter, and as well as I you have to check. And here also I you have to check. And as well as from with the help of the voltmeter R2 you have to check. And here also I and resistance. So like this you have to, what? You have to note down the readings. Okay. Now what you have to find? It is observed that total current I is equal to the sum of the separate current through the each branch of the combination. So here what we are finding, dear students, I is equal to, here you are finding like this, I is equal to I1, I2 and I3. So like this. See that resistors here, what we are finding, potential difference will be same. So here three resistance will be there. And value will be different, three resistance value is different. But potential difference will be same. Values are different. Okay. And also three different current here, three different resistors will be there. The different current flow will be different. But potential difference will be same. So here what will be same? Potential difference will be same. So you know that the relation you can find. The relation how we can find? V is equal to IR. So this you are doing, V is equal to IR. So R is equal to V by I. So R is equal to R here you are finding I, so that is why you can write like this. You can find the I here will be different. So that is why I is equal to, you can write V upon R. V upon R. So now we will say that V is equal to, see, I is equal to V by R, that you write. So that's why you can write here I is equal to V by R, you can write like this. So then P here, voltage will be different, so that's why V upon R1. So what you can write? V by R1 you can write V by R2 and V by R3. So like this way. Because you know that the potential difference will be same, so that's why V will be constant. Now you see that, so V means what? V is equal to, so look here now. So here V will be, what you can write? V1 R1, so that is why VR is equal to, V is common here, so V is, say look here now, so V is equal to 1 upon R1, 1 upon R2 and 1 upon R3, you can write 1 upon R1 plus 1 upon R2 plus 1 upon R3. Why? Because V is common there. So V by R, so is equal to, so V will be cut. So that is why 1 by R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So like this way you can find this. So this is the way. Thus you can conclude that the reciprocal of the equivalent resistance, of a group of resistors joined in the parallel is equal to the sum of the reciprocal of the individual resistance, sum of the reciprocals of the individual resistance. So this one we are noticing in the parallel series. So dear students, so now you have completed both the, which one? Series. What you are learning? Resistor in the series and resistors in the parallel. So the first one, the series, you have to remember V. You have to remember. Why? Because V is equal to V1 plus V2 plus V3. And the parallel you have to remember I is equal to I1 plus I2 and I3. Okay. So then there will be no confusion for you. Okay, dear students, so we have completed resistance of a system of resistor, both as well as resistors in the series as well as resistors in the parallels. Now, in the next video, we will discuss heating effect of electric current. Okay, thank you. Bye bye. Thank you for joining us.